Second thing we're talking about today is the difference between elements, compounds, mixtures, and solutions. Okay, so generally, there are four types of matter. There are what we have is called pure substances, and then the other main category is mixtures, and then each of those two can be broken down a little bit further. So in our pure substances, the most simple and the most pure is what's called an element. Alright, so an element basically has one type of atom, and that's it. Alright, the other type of pure substance is a compound, which can be made up of different types of atoms, but they're all combined in the same way. So there's one type of molecule that can be made up of different atoms. Other than pure substances, we have mixtures, and there's two types of those, heterogeneous and homogeneous. And we're going to talk about what those two words mean a little bit later. But first things first, elements. So, like I said a second ago, elements are made up of only one type of atom. The basic idea behind elements is that they cannot be split up into anything simpler. That type of atom is going to be that element no matter what you do to it. It doesn't get any smaller than that. It doesn't get any simpler than that. Alright, so everything on the periodic table that you see is an element, is one type of atom. Each of those little boxes down here. Some examples from real life that you might know of are some metals are elements. So copper, iron, gold, silver, aluminum, a bunch of other ones. Those are all elements. They're that type of atom and nothing else. Some gases are elements. Nitrogen, neon, oxygen, and then a bunch of other less common ones are pure elements. And then something that you use every day, graphite in your pencil, the lead in your pencil, is pure carbon. And then diamonds are also pure carbon. They're just arranged in a different structure, so it gives them different properties. And I mean, there's tons of other examples, but those are some ones you guys might be familiar with. Okay, compounds are made up of only one type of molecule, but it can have different elements in it. So when you have some kind of chemical reaction that combines two elements together, and then you collect a bunch of those molecules that are the exact same, you get a compound. Let me move myself over here. Alright. You can split up a compound, so you can break those molecules apart down into their separate atoms, their separate elements. But usually, splitting up a compound requires a chemical reaction to do, so it's not always easy. Right, some examples of compounds that you guys might be familiar with. If you've ever heard of alloys, which is where you mix metals together to give them different properties, those are examples of compounds. Brass and bronze are both alloys made with copper, and then some other stuff thrown in there like nickel or other elements. And then steel is an alloy made of iron and carbon. So that is a compound. CO2, carbon dioxide, it's what we breathe out. It's carbon and oxygen bonded together to make a compound. And then H2O, water, is hydrogen atoms, hydrogen, the element, and oxygen, the element, bonded together to make water. So those are compounds. You can split them up, but it takes a chemical reaction to do. All right, one step further away from the simplicity of elements and compounds are what's called mixtures. All right, and we have two main types of mixtures. There are heterogeneous mixtures, which is where parts of the mixture are not evenly distributed, not spread out evenly. And if you take two different samples from different parts of the mixture, they can look different. Or homogeneous mixtures, which is where everything in the mixture is evenly spread out, and any two samples taken from anywhere in the mixture are going to look identical. So you can remember which of these is which with the root words in the first term. So hetero means different. So the heterogeneous mixture can be different in different parts of it. And homo, that root word, means same. So the homogeneous mixture is going to be the same no matter where you're looking at it. Okay, so some basic examples of heterogeneous mixtures where they're different depending on where you look would be like when you pour your cereal in the morning. And if you take a spoonful from over here, it might have 2 orange Fruit Loops and 3 blue ones. And if you take a spoonful from over here, it might have a yellow one and 2 green ones or something, right? Not every spoon is going to have the same exact ratio of colors. All right, and then this one off to the right, this is oil and water poured together. So if you look, they're mixing, but it's not evenly mixed. The oil is more concentrated at the top with some bubbles down here that are on their way floating back to the top, and the water is below it. So if you took a sample near the top, it would have more oil, and a sample near the bottom would have more water. So it is not evenly mixed. Okay, examples of a homogeneous mixture that would be evenly mixed is coffee or tea, where once you make it, and there's no grounds or tea leaves or anything in there, all of the whatever has infused into it out of the coffee grounds and tea leaves is evenly spread out throughout the drink, right? A spoonful from the bottom or a spoonful from the top is going to look the same. We've got Jell-O, the water and the gelatin and the coloring and the sugar and all that. It's all evenly spread out, so any one spoonful of Jell-O looks the same as another one. And then mayonnaise. Mayonnaise has water and it has oil in it, like the water and oil here previously, but because of the way they make it and the fact that it incorporates eggs, the fat into it, it all ends up being evenly mixed together and evenly spread out, so that any one spoonful of mayonnaise you take is going to look the exact same as any other one. Okay, the most common type of homogeneous mixture is what's called a solution. So solutions have 2 parts to them, a solute and a solvent. So if we took that coffee from earlier and we poured some sugar in it, the sugar would dissolve and end up spread out evenly through the coffee, through the drink, until you separated it out again by boiling off the coffee or whatever. And it's important to know which is which. So the solute is whatever is being dissolved. So in this case, it would be our sugar. And the solvent is whatever is doing the dissolving. So that would be the coffee, right? Some other examples of solutions would be like salt water, where salt is the solute and water is the solvent, or any kind of drink that you're adding sugar to. Water typically it's what's called the universal solvent. So there are a whole lot of things that will dissolve in water and act as a solute. One example of a solution that you might not think of is the air that we're breathing in. It is a homogeneous mixture of all the different gases in the atmosphere, right? You've got nitrogen, oxygen, carbon dioxide, all kinds of other stuff. The one that is the most common is nitrogen, so we can consider that the solvent, and then everything else is kind of mixed in with it, dissolved into the nitrogen. So all the other parts of the atmosphere are considered solutes. All right, so you guys have a little short homework assignment over this, and then you should be done for the day. Let me know if you have any questions.